Hello and welcome back to this video number 2 on Microsoft Identity Access Management. And if you have not watched my video 1, I recommend you to watch the video 1 before you come to video 2, because there is a continuation of thought process that would help you understand this video better. Now, going forward, this video is a very important and interesting video that would revolve around authentication and authorization. There are many people who have some confusions around it. There are people who do not understand well the options available to them, what Microsoft offers you, and how can you leverage the best solution that meets your organization requirement in terms of security, compliance, complexity, cost, DR, right? All that is very important, high availability, and because identity is prominent, to make sure that you have a consistent availability of your services to your consumer. So it cannot be taken lightly, and anything that you architect, design, and configure has a major implication on your overall organization and obviously on your end users, right? So this has got an end user experience impact, this has got an ROI impact, this has a TCO impact, this has an impact on your entire cloud digital transformation journey. So it's a pretty important area of discussion today. Hope it makes sense. So without any further ado, let's dive into the presentation and see what this video is going to cover. We'll start with cloud only authentication. Then we'll move on into the single sign-on or federated identities, especially talking and comparing the three most commonly used single sign-on protocols, which would be SAML, OAuth, and OIDC. We'll not go deep into this because this topic itself would require for a deeper discussion a separate video, but you will definitely have a better understanding of what these protocols are, what are the key differentiator, and in what use case you would be using which protocol, right? So that should help you understand this. Also, we'll jump into the Azure AD Connect authentication option. This would be one of your decision making option here, that when you deploy the Azure AD Connect, which authentication option you should choose and what are the implications of it, pros and cons, end user experience, cost, infrastructure, operations. We'll go all 9 yards here. So we'll start with password hash synchronization, which is also referred as same as sign-on. We'll also work on Passthrough Authentication. Then we'll jump on the single sign-on options offered within the Azure AD Connect. That could be federation with ADFS services, or you could use Ping Federate, or you also have the option of seamless single sign-on, right? And obviously both video 1 and video 2 would be augmented with video 3 and video 4, where you would see the actual demo of all these features and concepts that we have established in video 1 and video 2. So please do not forget to plan your viewing on video 3 and video 4, because that's how you would consolidate all this information, right, in a real world scenario. So with that, let's move on. And we are talking about the first authentication option, which is a cloud only authentication. I brought this slide back from the video 1 just to make sure that I can explain you better. So in this case, the non-synced identities and the guest identities, which is B2B identities, are only going to be using the cloud authentication. That means they will authenticate with their identity and their password directly to Azure Active Directory, which is very simple. And if you remember, I have also given you an exception to the guest, one of the type of the guest identity, Azure AD B2B, which would be the users that you invite from another Azure Active Directory, whether there's an O365 tenant or Azure tenant, they would authenticate to their Azure Active Directory. Other than that, for all non-synced or cloud-only identities and guest identities would always authenticate to your Azure Active Directory. Your Azure Active Directory is the authenticator when the user types their credentials there, right? It's very straightforward. Now, when we go into the single sign-on or federated scenario, before we need to go into this, and many of us come from different platforms, some of you can be application developers, some of you could be from infrastructure, some of you could be from security. So I don't know what my audience is at this point, but depending on where you are, it needs to be established that what is our use case, what is the issue, what is the business challenge that we are trying to resolve with this federated identity, and then we try to understand what are these federated identities are. So first thing is that if we go back on NT 4.0 time, or back in early days of Active Directory, when there used to be an acquisition, or when you acquire a company or you merge companies, how do we use to allow access to resources from one organization to another organization? We used to create a trust between, domain trust or a forest trust between the two organizations. We have a physical network connectivity as one of our requirement, and then we can allow identities from one organization to access resources in another organization, right? If you are familiar and you have been in this industry, you know it very, very well. It is still being done in many cases, but you have a couple of compelling requirements here, that you have to have a physical network connectivity between two organizations, right? And it's fairly straightforward. Now, when we go into the modern world, in a cloud world, you have your audience is not limited to one organization. Your audience or your consumer of your services and application is global. You have people coming from all over the world, and it is impossible to conceive that these users would have a connection to your Active Directory or to let them authenticate with your environment, right? On top of it, your Active Directory is never exposed to the public network, should not never be exposed to the public network. That itself is a security nightmare. So when we talk about expanding your audience, when we talk about allowing your users to access it from different locations without a barrier of a physical network connectivity, without having identities at multiple places, right? Then how do we manage that? How do we see this modern world, the modern world that you and me live in, where people are accessing applications right and left? You have got Facebook, you have got this, you have got this, thousands of applications running on your mobile devices. Apps are running all over the places. Your workplace is not your official, office workspace. Your workspace is all over the world. So now the horizon has changed, the scope has changed, the dynamics has changed. And in that scenario, we need to think again in a very different way. The traditional way of allowing access to your services using a trust or sharing your identities with another user is no more even an option, right? It's just not physically possible. Sharing an identity is absolutely a ridiculous idea. Now, you do not want to give your identities, no matter who that person is or where that person is absolutely impossible to conceive. People still might do it, but from security perspective, from compliance perspective, absolutely not recommended. The trust that we talk about, domain trust or forest trust, is in most scenarios in these kind of challenges is impossible, right? So how do we address that? So we talk about, in that scenario, we talk about single sign-on, we talk about federation, we talk about federated identities. I hope this sets the ground before we go that route. And when we talk about federation, looks very complicated. In fact, it is not. If we try to analyze it in a very simplistic way, what is a federation actually means? Federation is interconnecting these identities without a barrier of a physical network connection, which is very important to understand. So as long as you have internet connectivity, you can have identities interconnect with each other. And then instead of using multiple identities to access multiple different applications, now you make it easier, right? You use the same identity to access multiple applications globally without having worried about where that application resides, and that makes all our lives easier. That makes this commodity more consumable and usable. Remember one basic fundamentals here, that it has to be user friendly, right? And as long as we can make our solutions user friendly, then we are good in business. If we ask user to remember 5,000 IDs, it's impossible. It's not going to be popular, it's not going to be consumable. So this is where the business case comes into picture. When I used to teach MCSE classes long back, I used to ask this question, say, hey, this is going into the same realm here, right? So instead of using the website name, let's say you need to go to google.com or you need to go to paloalto.com, or you need to go to Meyer.com, or you can very easily associate the business name and append the .com and get access to that information, right? But remember, if this would have been not the case, and you would have to remember every single IP address to connect to that particular website, how difficult it would be. And you and me would not be talking today if that would have been the case, because that would have never made this information technology as popular, as important, as vital as it is today, right? The same scenario here when we talk about single sign-on and federation here. Instead of using multiple identities compared to the IP address scenario that I mentioned, it is easier now, right? That's where the federation comes into picture. So this is extremely important from the modern cloud perspective, modern world perspective, and the world that we live into. And that's where the federation comes into picture, right? So interconnecting identities is the core of federation. Simplifying access to applications without the barrier of network connectivity is the real outcome of this effort. So how do we accomplish that? We have three different single sign-on protocols available at our disposal. Each of them has got their each use case and advantages, disadvantages, challenges. So the first one is SAML, which is Simple Assertion Markup Language, and now the current version is 2.0. Then we have OAuth 2.0, and then the third one is OpenID Connect, right, or OIDC. So let's try to understand these three. How do they fit into your landscape, which is important to understand, and we'll try to compare these three very categorically. So when we talk about SAML, SAML was introduced back in 2001, and then came OAuth in 2005, and then came OpenID 2006. So this years has some relevance here. It's just not given here for no reason, right? And current version we already talked about. Now remember, SAML does provide authentication, while OAuth is not actually providing an authentication. OAuth is created and planned and configured to use a more kind of an authorization, right? Not authentication. It's a more authorization framework, for the lack of better word, as far as the OAuth is concerned. While OpenID is truly an authentication provider mechanism or authentication protocol. So what does that really mean? Basically what happened is the SAML was introduced in 2001, and the applications that can support this protocol are obviously the right candidate to be used with SAML authentication for single sign-on, right? Now OAuth was introduced for a simplicity's sake, was allowing an application or authorizing an application to access another application or its services or data, right? Simple. My application is authorized. It's kind of a delegated authentication here, right? My application is authorized to use your application or use your data or use your services. That's what OAuth is all about, right? It was created for a different purpose, but then it lacked some of the security requirements and some of the initiatives that you need. It never had an idea that who is authenticating, because as I said, it's an application is being authorized, not an identity, right? So that's where this has got its challenges. And then OpenID was introduced as a layer on top of OAuth to address those challenges. So OpenID is an additional layer on top of OAuth. Uses the underlying framework from OAuth, but provides you the authentication. So it has an ID token concept, which it gives you the information about the requesting user identity, information, type, name, blah, 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 all the required claims that you need to know about that identity that is accessing that service or request is given in that ID token. And that's the difference between OAuth and OpenID. I can go more in details, but that would defeat the purpose of this presentation. I want to make it simple and easier, right? So now you understand that SAML, OAuth, and OpenID has three different types of authentication and authorization. So if you look into this table here, SAML does provide you authentication. OAuth, as I said, is an authorization framework. So it does not provide you true authentication. It's a pseudo authentication or delegated authentication. And OpenID does provide you authentication based, because it does provide you the ID tokens, right? Now, as far as the authorization is concerned, SAML provides you the authorization, OAuth provides you the authorization, OpenID does not provide you the authorization. OpenID is an authentication protocol. So now, based on this, because now we understand that, we can understand the use cases, best use cases, where would fit, where would you use SAML, OAuth, or OpenID. So SAML is a good candidate for all enterprise-based single sign-on. Any application that supports SAML is a good candidate for SAML authentication. By the way, it is not a well-suited protocol for your mobile apps. And mobile apps, probably the OpenID would be a better choice, which is what all in the modern world is going on, right? When we talk about OAuth, as I said, is an application authorization, pseudo delegation, or delegated authentication of an application to another application. So that's where it will work with APIs very well. So if you're working with APIs, API management gateways, that's where the OAuth comes into picture. And OpenID is single sign-on for consumers, right? So you can have your application pretty much being accessible from different identities. Take the advantage of social networking identities and any other identities, and that's where the OpenID comes into picture. So your mobile applications would be a good candidate for OpenID. Now, as I come from security background, so we definitely need to look into the security risk. So in the security risk area, SAML has got an XML signature wrapping to impersonate any user. That's a possibility. So there are ways to mitigate that. OAuth actually does not provide any kind of a security. So phishing. OAuth 2.0 does not support signature encryption, channel binding, or client verification. There's no client information. Instead, it relies entirely on TLS for confidentiality. So when you are using APIs, it goes without saying that TLS is a must. There's no way that you can do APIs on HTTP alone, right? Absolutely not doable. Absolutely should never be done. Should never be conceived. Now, when we go OpenID, obviously phishing, identity providers have a log of OpenID logins and make a compromised account a bigger privacy breach. So we got to be careful about what we do and what our risk mitigation strategy around each protocol. I'm not going to go into those details in this video. Sometime I will come out with a separate video around these security initiatives around these three protocols, right? Now, moving forward, let's just go a little bit deeper, not absolute detail, but let's try to see each of them. So let's start with the SAML. And SAML uses the concept of service provider and identity provider. So in real world, what happens is that, let's take an example, what would be the service provider. So for an example, in our Azure space or Office 365 space, it could be you can try to log into Azure portal, or you can try to log on to OWA, right? So as a user, as me, I'm going to try to log into OWA, hypothetically. And in that case, what happens is that my service provider, which is right now the Azure Active Directory in this sense, is going to provide create a SAML request and redirects the browser to the identity provider. And which is my identity provider here, folks, is an on-prem Active Directory. And here is what the challenge comes into picture. Can my Active Directory understand the token, SAML token? You know that is not possible, because we established that in our video 1. That is the limitation in Active Directory. So in this scenario, our identity provider would actually be an ADFS server, Active Directory Federation Services, because that is where the translation would happen. My Active Directory cannot understand the SAML token, so I need to have some intermediate in between, a kind of a agent or API or a broker that could change this SAML token into Kerberos, and then Active Directory can authenticate. So for all practical purposes, whether my identity provider is Active Directory, but to get to the Active Directory, I need to go through my Active Directory Federation Services, which is what I'm going to demonstrate to you in our video, right? So now what happens is a SAML request has been, the browser sends the SAML request to, in reality, to my ADFS server URL. That's the third one. And it presents the SAML token, right? Once the SAML token is received by my ADFS server, it goes back to Active Directory, verifies, Active Directory authenticates it, right? Identity provider authenticates and parses SAML request and generates an encoded SAML response. This is an XML format. Then it goes, my ADFS server is sending it back. The browser of my browser here sends the SAML response back to my service provider, in this case, which is my Azure Active Directory. And service provider, which is Azure Active Directory, validates the SAML response and user establishes a session. Now I am on my OWA. So pretty straightforward, except for because my identity provider in this case is Active Directory, I need something in addition to that to make sure that my Active Directory. Moving on to the second option, which would be the OAuth. Now let us talk about OAuth. And in OAuth scenario, the flow is a little bit more difficult to understand, right? In this case, the number one step is that user logs on to the application and wants to import his friends from social IDP. This is just an example. Facebook or Twitter. It uses the concept of OAuth consumer and OAuth provider. In this case, OAuth provider would be, in this particular use case, would be the Facebook or Twitter here, right? The user is asking this. So when the user is asking an application, so basically what we discuss is that an application is being delegated an authentication and authorization. So this OAuth consumer is that particular application. OAuth consumer, number one, and number two is the consumer, which is that API in my viewpoint. The consumer requests for request token and secret key from the OAuth provider. OAuth provider in this case being Twitter or Facebook or whatever. And in that case, once it is done, then the OAuth provider requests the token and secret key back to the API, right? And it comes here to the OAuth consumer, number three. Number four, the API. The OAuth consumer asks users for authorization and passes a link that contains the request token. The request token that was initiated by the OAuth provider, in this case the Twitter, is now with the end user, and it asks for the authorization from the user, right? Number fifth is the user clicks on that URL and containing this, which has the request token provided by the OAuth provider, and the API call passes the secret key. So whatever that request secret key was in that request token here, that's what created, is now passed back to the OAuth provider. Now OAuth provider asks the user whether they allow OAuth consumer to use their data. Now the Twitter or Facebook is asking a consent basically from the user that, hey, are you okay? And user, once it confirmed, user has the ability to allow or deny it. User confirms and authorizes the OAuth consumer to access their data. That's number 7. OAuth provider, which is Twitter here or Facebook, generates an access token and access token secret and forwards the user back to the OAuth consumer. So now it goes back to this, and now the user has this access token with the token secret. It sends back the secret back to the API, and as a result, now API is able to talk back to the OAuth provider, which is Twitter, and OAuth consumer asks for the user's contacts and include access token and secret, because this is already access token was generated by the OAuth provider, provided to him. It goes to the API. API sends back to the user, the OAuth provider, and the job is done, right? Not that very complicated. Looks complicated if you look into the diagram and Visio, but once you start understanding the flow, it is easy. There could be many OAuth flows that I'm not discussing in this video. That would defeat the purpose, and it will just make the video unnecessarily longer. But you understand the concept now. Now, talking about the next option is the OpenID, right? OpenID uses the concept of the relying party and OpenID provider. Now, in this case, what happens is that it is an authentication, while in the back in the OAuth, it was more of a delegated authentication and more of an authorization. There was no ID token in OAuth, while in this case you will see the ID token coming in. So the first is that the app provide their OpenID URL. It goes to this relying party. The relying party discovers the OpenID provider via XRDS protocol, which goes to the OpenID finds out which is the OpenID provider. And once the OpenID provider gets it, the OpenID provider generates the key and associated handle, and OpenID provider returns the key and its association back to the relying party. And number fifth step here is that once it gets it, oh, this fifth is already here. So fifth is there. Now number six is the user is redirected to the OpenID provider with an authentication request, which was initiated here. And then user presents the authentication request back to the OpenID provider. OpenID validates the request, authenticate users, and redirect user back to the relying party with the signed SSN, right? So this is already done. Now users present the signed assertion to the relying party, and the number 10 is the relying party validates assertion and creates the session, right? So this is an OpenID scenario. I think at a very high level, without going into monumental details and granular details, we have at least have a fairly good understanding about these three protocols. Let's move on. So folks, we have already talked about the non-synced identity and cloud identity, and the guest identity authentication, which would be done by Azure, right? So cloud only authentication, we have understood that. Now we have to cover the identities that are being synced, or the synced identity from your on-prem Active Directory. What are our options available to us through the tool that we use to sync on-prem Active Directory to Azure Active Directory, which is Azure AD Connect or AAD Connect tool, right? Now, in that space, Microsoft offers multiple choices, multiple options to us, which I have enumerated here as same as sign-on, single sign-on through EDFS or Federation, as well as you can also do single sign-on with Ping Federate. You can also do pass-through authentication, and you can also do through seamless single sign-on. So remember, these options that we are presenting here is only for your synced identity, right? Cloud identities we have already covered. Now, when we talk about these options here, there are few key considerations before you architect and design your solution. Number one is that where do you want to authenticate the user? You have an option to authenticate in Azure Active Directory, and you have an option to authenticate these users back to your on-prem Active Directory. Each of them, they have their advantages and disadvantages. We're going to discuss that, right? So because, as I mentioned, the synced identity authentication could be a mixed bag, depending on what option you choose and how you configure and how you architect your authentication for your synced identities, right? This is what we are talking about. We have already established the protocols that being used for single sign-on, and we'll go a little bit more details as we move further into this video, right? And the second thing is that when you start looking into these, another factor, one factor that you already understood, that where do you want to authenticate, where is this identity authenticating, because that has an implication. Number two is that what is your end user experience you want? You want to give them a most desired single sign-on option, or they are okay with a different kind of an option which may ask them to credentials prompt, right? That's the second choice. The third one is how complex or how difficult that solution is from cost perspective, from hardware perspective, from security perspective, from operational overhead perspective, right? So these are your key considerations, because each of these options would present you different pros and different cons, right? We'll go around each of them individually. So let's move on. And remember that for all these options, the common tool or commonality between them is that they are all synced identity, and they are all being synced through Azure AD Connect or AAD Connect tool, right? This is the key consideration. So the first option that Microsoft presents to you is a password hash synchronization, or is also referred as same as sign-on. In fact, the same as sign-on is self-explanatory, and let me try to elaborate on that. So as you know, when you use the AAD Connect tool, this is a unidirectional sync, right? And what does that mean is that you have the ability to sync your desired users and groups from your on-prem Active Directory forest It could be a multi-forest environment, which we discussed in video 1, to a single common repository of identities, which is Azure Active Directory, right? We know that. And this is common, right? Irrespective of whether you use the password hash synchronization or whether you use a single sign-on option, this is common to all the 4 options that we are going to present. So these identities would be synced using the AAD Connect tool, and identities would be synced, and you can have a choice. You can do the filtering. You can sync it from one Active Directory forest. You can sync it from multiple Active Directory forests. You can sync all identities. You could sync a subset of identities. This is all up to you, right? And we will talk about, once we go into the demo, that how can you filter your identities based on OUs or based on extension attributes. That is very much doable. Pretty easy to do it. Trust me, the deployment of AAD Connect tool generally is less than a 30 minutes time job, right? So it's not that complicated. As I said, it's very simple. And that's where the cloud features that we mentioned in the very first video, the simplicity, agility, the speed comes into picture. Trust me, it's not that hard. And so once we get into the demo, you will see it. Now, what is so unique about this option, which is same as sign on, that in this option, not only you sync your user identities to Azure, but you also sync their passwords in a hash algorithm. Obviously, because they are hash, they are inaccessible to anybody, right? They are completely secret, completely encrypted. Nobody has access to that. Now, once your passwords are synced into Azure Active Directory, you have your identities synced, you have your password synced. So basically what you accomplish is that instead of provisioning these users manually every single time, you have automated the process of creating these users in the cloud, because your passwords are also in the cloud, right? Remember that. That's the distinguisher here. And as a result, you don't have to worry about provisioning, deprovisioning your objects or identities into Azure. And also, you have also synced the password. So basically, as a user, you don't have to remember 2 separate identities and passwords to log into your regular laptop or desktop that you're connected to your corporate network, or when you try to access any cloud application, right? So that's why it is same as sign-on. From end user perspective, their identity remains same and their password remains same. Now at this point, it is important to mention that the identity sync, or the identity means to users and groups here, sync schedule is 30 minutes. So if you make a change, you add a new user, you modify group membership, it might take up to 30 minutes to show up in Azure Active Directory. The password sync is almost instantaneous, right? It happens generally within a matter of a minute time. So by the time you change the password in an Active Directory and the end user goes and open application, he's good to go. So they don't see any kind of a latency generally, by and large. There could be few exceptions. It might take slightly longer, a minute and a half or so, but in general, the end user experience perspective, they don't see any major impact by the password change option. It's not that you have to wait for 30 minutes to sync the password, right? That's important to understand. So what is the end result here? And who is authenticating? This is important. We asked this question earlier. In this scenario, it is the Azure Active Directory authenticating, not your on-prem Active Directory. And that makes a significant impact in your solution, right? Depending on who is authenticating. So though these identities are synced, and remember, when you are syncing these identities, you cannot make any changes to these identities or groups, synced identities or synced group in Azure. If you have to make a change, you have to make a change on-prem, and then the changes will be synced. And it makes sense, because this is a unidirectional sync. It cannot sync it back. So if you start making changes in Azure, this would all be out of sync. This will just get a complete chaos there. So if you have to make a change into any of these objects, you will make a change into on-prem Active Directory, and then it will show up in Azure Active Directory. Now, we have understood that who is authenticating you is an Azure Active Directory. So what are the advantages or disadvantages of this solution, or pros and cons of this approach? So number one advantage here is this is the easiest and the simplest and most cost-effective way of doing the syncing your identities, because what it takes is that just deploy the AAD Connect tool. And to be honest, though it is not advisable, you could actually deploy AAD Connect tool on your own domain controller, right? That's very doable. Now, but in general, you would have a separate VM, dedicated VM, controlled VM, some hardware limitations. We will talk about the hardening of this AAD Connect server in our demo. But this is the only thing that you need is most likely one additional VM. That's all you need to sync the identity. So this is a simplest, easiest way of doing it. And as I mentioned, to do this, actually deploy it, download it, deploy it, is about a half an hour task maximum. It's not going to go beyond that. So it is that simple. So that's a huge testimony. Number two is, which is even bigger, when you talk about disaster recovery, high availability, think about it and think logically here, because any solution or architecture that you create for this, you need to make sure that the users can continue accessing their applications, right? And in that case, this has an advantage. The reason being that after the identities are synced to your Azure Active Directory, they have a zero dependency on on-prem Active Directory for authentication. Reason being, this is why I mentioned earlier that where are they authenticating to? They are authenticating to Azure Active Directory. So God forbid something goes wrong in your environment, in your on-prem data center, or your domain controllers, network connectivity issue, or maybe this environment is down, data center is down, there is a catastrophic event in your environment. As long as the users have internet connectivity, they are not impacted because they are authenticating to Azure Active Directory. And remember, Azure Active Directory is a multi-tenant managed identity services, right? We established that in video 1. So irrespective, if your domain controllers are down, your networks are down, your data center is down, there is a catastrophic event in your environment, your users would still have access to your cloud application, which is monumental for friends. Not only it's simple, but the other side is that you really don't have to worry about a DR or high availability here, right? The only thing that you might miss in that case, in case of disaster, that first of all, if it's a true disaster, you're not making any changes in your on-prem Active Directory. But if it's just a network issue or something, and you make some changes onto the in your on-prem Active Directory, during that process where your AAD Connect is not available, the changes would not be synced for that period, right? That's all. And once your AAD Connect is fully operational, the changes would be synced back. And this is very straightforward. So if you look from the pros perspective, it is very, very simple to deploy. It is fastest to deploy from a speed perspective. It has a very limited hardware requirement, right? Very, very limited. And then on top of it, you really don't have to worry about deploying of a high availability or DR solution. Pretty much independent of your on-prem Active Directory environment. And as long as your Azure Active Directory is running, which it should be running because this is Microsoft managed services, you're good to go. Your applications are available. So your application availability is pretty much guaranteed to 99.9% availability as per Microsoft SLAs, right? And that is phenomenal. Now, what's the downside? The downside is that users would be prompted every single time they launch a cloud application and need to provide their credentials, right? And that could be irritating and annoying. Obviously, the browsers could have cached the credentials and passwords, so that makes it easier, but it still is annoying, right? Now, the users, especially the users who have already experienced the single sign-on with some other application or something, they would start bitching about after some time. So that's the downside of this. And down the road, if you all want to extend your infrastructure for single sign-on for some other purposes, some other application, you have not created anything for single sign-on here, right? When you go to the single sign-on solution, you might be able to extend your infrastructure for, in some scenarios, of single sign-on to other applications as well for for single sign-on option, right? So that's the nutshell about the password hash synchronization. Very simple, cost-effective, no hardware, no worries about DR or the high availability. Some customers do the AD connect staging servers, which maybe it might save you about half an hour or so, but most customers do not even deploy the staging connect server. That's a standby AD connect server. In case something goes wrong, you can bring that back pretty easily, pretty quickly. You might save half an hour by doing that. Otherwise, you can redeploy the AD connect server and it works pretty fine. You don't have to really worry about it in case of really something happening to your AD connect server, right? So that's the password hash synchronization. I think it's still straightforward. So let's start with ADFS scenario. Now why we need an Active Directory Federation services. We established that in our earlier discussion when we talked about SAML protocol, because this is what is going to use SAML, and we know that limitation that Active Directory has, because Active Directory cannot authenticate based on SAML tokens. So we need to have an ADFS server, Active Directory Federation services, that would do the required job for you to accept the SAML requesting token and then ask Active Directory to authenticate the user. And once the authenticated user comes, authentication comes back from Active Directory, send the authentication token back to the Azure Active Directory, right? This is where the role of this ADFS servers are. So that adds complexity, that adds some challenges there. Let's talk about those challenges. First of all, this ADFS server you would be running in your data center, and obviously this is a single point of failure. If that ADFS server is running into some issue, or even you go with a normal patching or update process, then and reboot the ADFS server, your users are deprived of their services. They cannot authenticate, and you really don't want it. So in order to do that, you will have to have more than one single Active Directory Federation services server, right? So that means bare minimum you would need two, and we'll go further that you might need even more than that. So you need an ADFS server farm, and as these two servers are, ADFS is not a cluster aware application. That means in order to make sure that they're available in the high availability side, you will also need load balancers, as I'm showing in your diagram here, right? Two ADFS server minimum and the load balancer, and single load balancer could also be a single point of failure. So now you need to have a cluster of load balancer or two load balancers paired or whatever, and generally you would use a third-party load balancer. So now see here what we are doing. We are adding additional servers, we are adding additional complexity, we are adding additional overhead. All fair, and it is doable and it should be done, right? There are reasons to do that, but there is also impact. Now in order to do that, that's all fair, folks, right? So far so good, but it only addresses your internal users, because your Active Directory is internal to your local network. It is not exposed, and it should never be exposed to the public side. So what happens to my users who are remote? Anybody who is traveling, especially now with COVID, everybody is remote. Now what happens? Do we deny them, or can they not use their email, SharePoint, Team, any other cloud application? That would be a complete disaster, right? So how do we handle that? So, and that too securely. You definitely do not want to put your ADFS servers into your public network or DMZ. So in order to accommodate that and do it securely, you need to deploy the WAP server or Web Access Proxy server, right? So Web Access Proxy server is another pair of servers that you would need to deploy in your DMZ. And again, a single server would bring the single point of failure, so you need at least two of them, and that too also has to be load balanced. So that's the reason this box here is showing you the DMZ portion. So all external users would hit the load balancer VIP, and then it will go to the ADFS web proxy servers. ADFS web proxy services would terminate the user session, and will talk internally to the ADFS server, get you authenticated, and then users are good to go, right? So that's the scenario. But is that enough? Now, especially when you are working with a large environment, and you might have done all this good, but what if the data center goes down? Then what, right? And I have seen people or something happen and people deployed a single ADFS server, never worried about it. And I have seen organizations and CFOs and CIOs and CEOs yelling on the IT staff when they see an outage and they cannot access, the organization cannot access their emails and SharePoint, and they come back and say what happened, and the outage is happening for 4 hours, 8 hours, 2 days, and they say, hey, we are paying so much money to Microsoft, why do we have outage? And obviously it's not a Microsoft fault. Microsoft says, hey, we are good here. So ultimately what happened is that if you have not considered all these, fallback scenarios, then you might get into outage. So how do we handle that? Second point that you need to consider is that especially for larger organizations who are, global organization and multi-region organization. Now, if you have got this data center running in Chicago and your users are all over the world and people are coming from EMEA or EU or whatnot, and they're all hitting this ADFS server over the WAN, that is also a challenge, not only network traffic, but guess what? If there is a network connectivity issue, all these other users are now impacted. So it's good it looks very lucrative, right? When you look into single sign-on, but you have to understand the implication here. So how do we handle that? Now, there are ways to handle it. You could have replicated this infrastructure in multiple data centers. And when you do that, you also have to worry about now DNS, because DNS is only one, right? URL is only one. So now you need to worry about how do you do the DNS geo load balancers or geo DNS, right? That's another challenge. So there are multiple challenges that you have to deal with it when you get to the ADFS solution. You could have deployed in a second data center. You could have a geo DNS load balancer behind it. You could deploy it in multiple regions. And there is a smart trick that I have used without even using the GeoDNS load balancer, at least for internal users. You could do that. You could deploy a parallel ADFS infrastructure into Azure as infrastructure as a service. That's another option, and let the traffic come. All the internal traffic stays internally, but all external traffic from the day one comes from the Azure, and that becomes your tentative DR location. So there are multiple options available to you, but you need to plan it. You cannot just say, hey, here is the single sign-on solution, and it's all good to go, and then next 6 months, 8 months, you get into an outage, right? And it's not an outage created by Microsoft, it's your data center outage. Second thing is that you are still dependent on your on-prem infrastructure. So in terms of pros and cons, when we talk about, once we understand this, the pros is that end user experience is perhaps the best, and because end user doesn't have to type any credentials, and as long as they are on the corporate network, they're already authenticated to their on-prem Active Directory. It will take that integrated authentication and let the user authenticate without typing anything, right? Without typing their passwords. So that is end user perspective. That is perhaps the best experience. Second thing is that you can leverage this ADFS infrastructure, because this adds the SAML component into your Active Directory, and also leverage other applications from a single sign-on perspective, right? So that's an additional advantage. In fact, I have a demo on Azure B2B solution for SharePoint on-prem. So by using the same ADFS infrastructure, I was able to allow users authenticate to your on-prem SharePoint using Azure Active Directory. And that's another option. You could do multiple things around it. You can have other SaaS services, SaaS applications that you're running in your Azure, right? They can also take advantage of this infrastructure. So There are multiple advantages from that perspective, and this is an enterprise level solution. So most customers, despite the challenges that I mentioned, actually go for it, and there is a reason, there is a real business case for that. But when you define this solution, all good points here, make sure that you take into consideration your HA and DR carefully. Otherwise, as I said, you might burn yourself, right? And that is the ADFS. I'm not going to explain you how does the authentication happens here, because I think we have already discussed that when we talked about SAML. ADFS is the key element here to work as an intermediate between your identity provider, which is Active Directory, and your service provider, which is your application, right? So this is where it rubber meets the road kind of a thing, and that's where the single sign-on with the ADFS comes in. I have not created a diagram for ping Federated because I don't think I will be able to demonstrate you in my lab. This is already big, but it is the same thing. You, instead of using an ADFS server, you would use the ping Federated servers, but pretty much everything else remains the same. And in terms of selection, you can also select when you are selecting in the AD connect option once I show you in the demo, right? Now, moving forward to the next option is the seamless, no, I think there was one more before that. The pass-through authentication, right? The pass-through authentication is an interesting concept which do not require your ADFS servers or ADFS infrastructure. It would let you directly authenticate to Active Directory by using the Azure AD proxy, because remember, it is either Azure AD uses a Kerberos as an authentication protocol, and Azure AD proxy is meant for Kerberos based applications. Not only it will, you can have a single sign-on with your, using your Active Directory to be authenticated as an IDP, but any other application that you have in your on-prem environment that uses Kerberos as a protocol can also take advantage of the Azure AD proxy, right? So basically what happens in this case, that when you deploy the AD Connect tool and you choose the pass-through authentication, when the AD Connect is deployed, the same AD Connect server also becomes the Azure AD proxy server, the first Azure AD proxy server. And when in terms of authentication, without going into the HA option here, whenever the authentication happens, the internal user goes to the external user goes to the request for an application. Azure Active Directory says, okay, I have this as an Azure AD proxy services. I need to send it back to the on-prem, and it sends it to the on-prem Azure AD proxy services. This is all configured in Azure AD proxy, and Azure AD proxy in turn sends it to the domain controller, get it authenticated, and you're good to go, right? Now again, the same challenge, if you leave it in the one server here and that server goes down, you have the similar challenge that you have with ADFS. So you end up doing Azure AD proxy here as a second or 2-3 servers and put it behind the load balancer. Now you probably don't need any DMZ here, because your Azure Active Directory proxy itself is a DMZ. So you eliminate the DMZ requirement here. You don't need any web servers here, but you still need some kind of a high availability for your Azure AD proxy services, right? And it's very good solution. I haven't seen many organizations using it so far, unfortunately. But if you really want to see a good Azure AD proxy demo, then you can go to YouTube and look for my name, and you will find an Azure AD proxy demo that I did it for on-prem OWA. I believe I did that a couple of years back. So if you really want to see the power of Azure AD proxy, you might want to watch that video. This is another one, which is seamless single sign-on or opportunistic single sign-on. So in this case, we don't need anything. We don't even need ADFS. We don't need Azure AD proxy services. We can just let users authenticate directly to your on-prem Active Directory, right? This is pretty cool as well. What happens here is that in this scenario, the Azure Active Directory impersonates in your Active Directory as a computer object. And once we go to the demo, I will show you that object. It creates that object here. And when the users who are connected to your internal network, who are already who has the capability to authenticate internally to your Active Directory, when they go there, they can use that impersonation and authenticate directly to your Active Directory without worrying about it. Now, as I said, this is an opportunistic SSO. So as long as the users are connected to your corporate Active Directory and have a network connectivity, they're good to go. But what about the remote users? Or whatever if it doesn't work? So in case if the users are remote, or in case this single sign-on is not working, it would fall back on the option that the fallback option that you choose. And in terms of the fallback option, you have both the choices. You can use the pass-through authentication with seamless single sign-on, or you can use the password hash synchronization with seamless single sign-on. So let's try to understand what I intend to say. If you are using hypothetically the password hash synchronization, which is the most common use case in this scenario, if you're using the password hash synchronization with seamless single sign-on, now the user was on internal network, he gets the single sign-on experience, voila, good. Now the same user goes back home, or he goes to a hotel, and now he tries to log in. He's no more connected to his internal Active Directory. So how does it work? But by the way, the passwords are already synced to the Azure Active Directory as a fallback option. And at that time, it would be prompted for credentials. His credentials are already there. His password is already there in Azure Active Directory, and he would be able to authenticate directly to the Azure Active Directory. The difference here, again, to the point that I mentioned in the first introductory slide on AD Connect, is if the users are internal and are able to connect to your Active Directory domain controllers from network perspective, they would authenticate directly and they would get a single sign-on experience. If the users somehow are not able to connect to your domain controllers from a network perspective, then they would fall back into the fallback option that you have chosen. If you have used password hash synchronization, they would be prompted to that, and if they have used the pass-through authentication, then they would fall back to that. But pretty cool stuff, and you would love it once I show you in our demo. All right. So with that, I think we come to a conclusion of this particular presentation, video 2. I hope I have given you enough information to think about it, to consider your solution, consider your approach. And needless to say, once you go to the video 3 and video 4, which are the actual demo, you would have a better understanding of all what we have been talking for last 2 hours in video 1 and video 2. I cannot thank you enough for your patience and your interest in the videos that I create. I truly appreciate it from my bottom of my heart. I hope that you like it. I hope that you find value in all these videos and it helps you. With that, we will conclude this video here, and I will see you in video 3 momentarily, or whenever you want to see that. Thank you again. Thank you very much. Have a best of your day or night, wherever you are, whatever part of the world you are. Stay safe, stay away from COVID, and we'll talk soon. Bye-bye.